Let's welcome the next demonstration given by Tang Waiqing, Yang Qingquang, Yu Qingwing. Their project code is MWH02a-21, and title is Autonomous Docking and Recharging for Indoor Drones. The demo group, please start your presentation now, and remember to turn on your microphone and camera. Share the PowerPoint if you have one. Thank you.
Is it anyone can see the PowerPoint right now? Okay, now let's get started. Good afternoon, everyone. My name is Oscar Yu, and my teammate Gary Young and Vincent Tang. It is our pleasure to present our final year project. This project aims to develop a fully autonomous drone charging solution for indoor environment. The DJI Tello EDU is used for the development. The project is divided into three main parts, including the navigation, charging mechanism, and the charging dock design. And for the navigation, we implement two different strategies. For the long distance, an Arduino marker is used for locating the station. The drone can navigate to the station from 12 meters away if the size of the marker is 20 centimeters squares. And when the drone is moved closer to the charging platform, a mission pack is used for fine-tuning to the correct landing position. And the image from the front camera of the drone will be used to navigate to the Arduino marker, and the acceptable landing area will be adjusted by the bottom camera and finally landed on the platform. And now I will let Gary talk about the charging mechanism.
Thank you, Oscar. In this project, we will need to develop a mechanism to charge the drone without human interaction. However, the drone is not able to charge when it is powered on. To turn off the drone, we physically hit the power switch by soldering a wire to it and use Arduino to simulate pressing the button. We mount 4 metal plates both on the drone and the charging platform for connection. 2 of them are positive and negative contact used for charging. One is connected to the power switch to turn the drone on and off, and the last one is used to balance the drone after landing. To achieve higher quality contact, we use 4 electromagnet to load the charging contact when the drone is successfully landed. Now, I'm going to talk about the charging dock design. The platform design is matched with the Tello drone with the funnel shape perfectly. It can improve safety and accuracy during the landing process. The holding box can make sure the electromagnet is secure and to provide well-distributed force to load with the charging dock. A component box will be used to hold electron component and mount under the landing platform. Now, you can see the landing is smooth and reliable. And now, Vincent will show you the result.
Thank you, Oscar and Gary. We will now show a video to demonstrate the whole charging progress. On the right side is an external camera to capture the drone's movement. You can see the drone, Arduino marker, and the station. On the left side is the computer screen. The red text on the screen showing the command sent to the drone and the drone information, for example, battery status and the landing progress. The window in the middle is showing the drone camera with the coordinate of the detected marker and highlighting the marker which is currently using for navigation. And now we will play the video. Now the drone is approaching to the Arduino marker. And it is adjusting its angle to align with the charging station. And finding the landing position now. The Arduino is turning off the drone, and when the LED blinks in blue, it means the drone is charging now. As you can see, the voltage is 5.2 volt and the current is about 0.8 amp. To summarize, the successful rate of this charging system is around 80%. Drone can land in the station and perform charging within 1 minute. The maximum charging current is 1 amp, and the charging voltage is 5.2 volts. The battery can be fully charged in 55 minutes. And that's all of our final year project. Thank you for listening.
Thank you for your presentation. Now it's time for Q&A section. Anyone who have questions can directly ask the demo group.
As mentioned, according to a question, as mentioned, our project, we use our marker to align with the charging station, and the OpenCV can return the coordinate, including the vertical, horizontal, and the distance coordinate. So we can control the drone based on the coordinate.
May I ask a question? Will you continue develop this project? Maybe like it will detect if the charging port is occupied by another drone, then it will fly to another charging port automatically. Will you future develop this function, or it is? Yeah.
Thank you for the question. I think this is a future improvement that we can make to increase the number of drones to make a whole system.
For the power level, and we after implement our project, and as the video showed that the voltage is near to 5.2 volt and the current is near to 1 amp. It is similar to plugging in the USB to charging the drone. That is our result.
If there's any obstruction on the charging station, what is the expected behavior of your drone?
Thank you for your question. Actually, we didn't implement that scenario. We just make the charging station to charge the drone and the navigation.
Okay, thank you.
Thank you.
If there's no further questions, we'll invite the next group. Then